Calculus Kids. This is Dr. Callahan with Week 11 Friday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up blog. All right, I'm just going to jump right in. So this is our second day with volume. Your guided notes starts on this page for Week 11 Friday. Here is page 1. It's just like another visual way of kind of seeing this and seeing how the formulas are made and whatnot. So page 2, page 3 right here is basically some of the questions from your textbook, and I have the video guided notes link right here where you can click on it and it'll have an explanation for these questions from your textbook. It does move a little bit further ahead because right now we're only talking about the disc method. I haven't shown you guys the washer method yet, but we will. If you would like some additional practice when it comes to your free response questions, I do have them here from previous years that is related to area and then also volume. So for each of the 6 questions, reflect on the following. What is the question asking you to find and what information is provided? 2, what formulas and theorems do you need to memorize it? 3, how is the problem set up? And 4, are the different parts related and dependent on one another? This page right here is going to be your guided notes for today, and we're going to go over the 1, 2, 3, 4 different questions. Within each of the 4 questions, there are parts A and B, so that we can see the difference of the rotations. And so with that said, let's just go ahead and jump right in to get this done. All right, so let's go ahead and get started on this page right here. Okay, so let's take a look at question number 1. It says, let R be the area enclosed in the function y equals 2x squared, the horizontal axis y equals 8, and the y-axis. Find the volume of the solid generated in the shaded region. Okay, so I'm going to go ahead and do B. And if you look at B right here, it says that this is rotating about the y-axis. Now, oops. The y-axis is this axis right here. If I'm going to be rotating around this, I would have to have a horizontal rectangle disc that's going to be rotating around this axis, generating the discs or the circular disc that you're going to be adding together. Okay, so then if you think about this right here, if it's the axis of revolution is going to be vertical and it is on the y-axis, then you know that your rectangle is going to be a horizontal shape, and you're looking at the perspective of dy with x solved in everything in terms of y. So that means if y equals 2x squared is your equation, you will have to solve for x, which means you will have just kidding, x is equal to y divided by the 2 with a cube root, or x equals y over 2 to the 1/3. Okay, so then now that we established that, and this is the one that we're looking at because it's a right minus left, let's go ahead and plug into the formula. So I have volume equals pi integral, and here it's from 0, and I think it goes up to 8, so 0 to 8. And then remember, you have r of y, which is going to be the radius of the bar right here, or the height of this rectangular bar. And in order to find the r of y, it is going to be the right minus the left. Now, the right part of this is going to be cube root y over 2 minus the left side right here, in which case it is just going to be the axis of 0, so minus 0. And now that I have r of y, I can plug it into this formula. So I have y over 2 cube root squared dy. Well, I don't like the way that it's written, so I can write it as y over 2 to the 1/3, but there's a square here, so to the 2/3 dy. All right, so then let's go ahead and integrate this. So when I do that, it'll be a +1, which is a 3 over 3. 5 and 2 gives me a 5/3. Now you're going to have to go ahead and divide the entire thing by 5 over 3, which is the same thing as saying timing it by 3 over 5. So then my volume is equal to 3y over 2 times 5 is 10. Y is going to be to the 5 over 3. Evaluate that from 0 to 8. So then let's plug in the upper bound, which is going to be 3 over 10. Y is 8, 5/3, minus, well, that's just going to be 0. That's a lower bound. Okay, and then don't forget your pi. So once you use your calculator and try to figure out what a to the 5 over 3rd power is going to be, you plug it in. It's 120, or I'm sorry, 12.095 pi unit cubed. And this is your answer. Now I want you guys to go ahead and try for letter A. All right, I'm going to go ahead and show you guys the answer. It is this right here. Take a look at the steps, pause it. All right, let's go on to example number 2. All right, I'm going to go ahead and take a look at A. It says find the region R, area enclosed. So keep in mind that this right here is y is equal to x cubed plus 2. The horizontal line y equals 2. And a vertical line x equals 0. And x equals 2. Find the volume of solid when the shaded region is rotating about y equals 2. So here is the y equals 2 line. Well, if this is going to be rotating about the y equals 2 line, it means that y equals 2 is this line right here in blue. If I'm rotating around this, I will have to go around this way, which means my rectangle has to be vertical. And if you think about it, it will be this equation right here, where everything has to be solved for y, which it is, and has to be in terms of dx, so in terms of x. So let's go ahead and find what our x is going to be, which is going to be top minus bottom. So the top part of this rectangle is going to be top minus bottom. So x cubed plus 2 minus the bottom, which is y equals 2, so minus 2. So r of x is just going to be x cubed. Now I need to go ahead and find the intersection or the upper and lower bounds. Well, it's telling me that starting at 0 to 2, so I'm just going to put 0 to 2, r of x squared, so that's going to be x to the third square, so x to the 6, dx. So then let's go ahead and do that. Don't forget your pi. 6 plus 1 is 7 divided by 7. So your volume is going to be pi, and you're going to have x, or 1/7, x to the 7th. Evaluate that from 0 to 2. So let's plug in the upper bound, which is going to be 2 to the 7th. Oops. Minus the lower bound, which is 0. Now, if you use your calculator and works that out, you're going to have 128 over 7 pi unit cubed. Now that I did this one for you for A, 3A, I want you guys to try for 3B. Pause the video and give that a try. All right, go ahead and take a look at the answers, you guys. You should have 3.2 pi unit cubed. I'm going to go back to number 2. Okay, so for number 2, I'm going to go ahead and do B. And with this one, it says, let the region R be the area enclosed in the function y equals e to the x plus 2. The horizontal line is y equals 7. In the y-axis, find the volume generated. Okay, and then it says rotate about the y-axis. So here is the y-axis. And so if this is going to be rotating around this axis, it's going to go in this direction, which means that your rectangle has to be in a horizontal format. And that means you have to solve everything in terms of y with x equals like this. So I might have to readjust this a little bit to solve for that. So let's do that. So I'm going to do y minus 2 equals e to the x. I need to get that x down, so ln y minus 2 equals ln e cancels, which is equal to x. So now you solve that. Let's now go ahead and see if we can go and find r of y, because we established that this is the equation to be using. So r of y is going to be right minus left. The right is going to be x is equal to ln y minus 2 minus the left. Left is 0 because it's the y-axis. So then ry equals ln y minus 2. So let's go ahead and plug this into the equation. Volume equals pi. If you look at this, it appears that it is going from 0. Or actually, I'm sorry, it's not going to be from 0 because, let's see, the horizontal line y equals 7. Because when you're looking for the interval has to be in terms of y's, like that. And so we're looking at from here, which is y is equal to 3, up to here, which is y is equal to 7. So 3 to 7, ln y minus 2 squared dy. And if you go ahead and find the integrals of this, whoops, let's go back to this here. Uh-oh. You will find out that when you plug in the upper and lower bounds from 3 to 7, your volume is going to give you a 4.9 pi unit cubed. Now go ahead and give A try on your own. And if you would like to take a look at the answers, here it is. All right, let's go on to number 4. Okay, so for number 4, I'm going to go ahead and work on A. So for A, it says the area enclosed the function is going to be, so this piece right here is y is equal to 2x, the 1/3. The horizontal line is y equals 2. And the y-axis, find the volume of as it's generated around the line y equals 2. So if it's generating around the line y equals 2, I will have to imagine that it's going to go in this direction. So the rectangle that I'm going to be using has to be something like this. It has to be vertical. Okay. And if it's going to be vertical, then I know I have to have everything solved for y. And it has to be in terms of, I'm sorry, solve for y in terms of x with a dx. And then keep in mind your upper and lower bound are going to be on the x-axis, and it looks like it is from 0 to 1 is my upper and lower bound. And then let's go and find r of x. R of x is going to be top minus bottom. So the top of this looks like it is just 2 minus the bottom, which is touching this curve right here, which is 2x to the 1/3. So then, and now that I have that, plug this into volume equals pi from 0 to 1, 2 minus 2x to the 1/3 squared dx. You will probably have to use substitution. So then when you go ahead and integrate this and you plug in the upper and lower bounds, your volume is going to be 0.4 pi unit cubed. Go ahead and try that with B. And here is your answer. All right, you guys, now that we have gone over, I have gone over 4 questions and you have gone over 4 questions on your own. I feel like you guys are now ready to go ahead and practice this a little bit on your own. So I do have a quizzes that would like you guys to practice with. So first thing, I have 2 things I would like you guys to do. One is a example of volume. So with this one, I'm just going to set it up for you guys. 16 different slides that I want you guys to go over. So you're going to go to joinmyquiz.com, type in 22604434. So I'm just going to click on it so you can see what it looks like. Once you get there, you're going to have your name there and then just go ahead and get started. And when you do start this, you'll be able to see the slides I have here. Click on next on the bottom right corner and read the 16 different slides. Look at the examples, look at the techniques and strategies that are used, how are things set up accurately. Now, once you're done with this, oh shoot, I didn't even share that. I'm sorry, hold on. That was bad. All right, hold on a second. It's great that I talked about it, but I didn't really do a very good job screen sharing this. Hold on. So you're going to go back to joinmyquiz.com 22604434. And I'm going to do that. There's 16 slides, so make sure you do that. Now, when you're done with this, I feel like you guys are ready to go ahead and practice on your own with areas and volume. So then you're going to go to 15 questions of practice. And you're going to do quizzes one more time, but with actual questions. So just join myquiz.com, type in code 414788802. So I'm going to go and click on it so you can see what it looks like. Type in your name, get started. And then It's going to do the countdown. And here you have a question where you're looking for the volume evolving around 1, and then just make sure you guys pick the right one by showing the work. All right, you guys, and that's basically it. I would highly suggest that you go over the notes for this week because it's our day 2 of volume. And other than that, I hope you guys have a wonderful Easter and have a wonderful break. As always, you guys stay safe and healthy. Take care.